We're about to do a technique called trig substitution for integrals. And trig substitution works this way because we are going to have expressions that involve x squared. So we're going to have something like a squared minus x squared, where a is a number. We're going to have x squared plus a squared. Again, a is a number. And we're going to have x squared minus a squared. What we are going to do is we're going to associate with each of these one of the three trig Pythagorean identities. With this one, we're going to compare it to 1 minus some quantity squared, which is going to involve x. And looking at this, we will see that this can be related to the Pythagorean identity 1 minus sine squared theta. And we know this will be, of course, cosine squared theta when we finish. Looking at this, if we think of the a squared as eventually a 1, this is something squared, x squared, plus 1. This is related to tangent squared plus 1, which will get changed to secant squared afterward. This can be transformed when the a squared becomes a 1 to something squared minus 1, which is reminiscent of the Pythagorean identity secant squared minus 1. And that is tangent squared. First example, we're going to look at the antiderivative of square root of x squared minus 9 divided by x cubed dx. First step, I'm going to write x squared minus 9. I want to get a 1 for the number, so I'm going to factor out a 9, and it's x squared over 9 minus 1. And I look up here and I see that's a perfect example for me to put in secant squared. So this will be 9 times secant squared theta minus 1, which I know will become 9 tangent squared theta. Now I create what I call the key for this problem. What I look at here is I see that secant squared got to replace x squared over 9. So I go x squared over 9 is secant squared theta. First we'll take the square root of both sides. We get that x over 3 is secant theta. Once you have this step, guys, you're going to create a triangle whose angle is theta, and you are going to, given that x over 3 is secant, you're going to put in the correct sides and use the Pythagorean identity to get the missing one. So secant, we know, is the reciprocal of cosine, so instead of it being adjacent over hypotenuse, it is hypotenuse over adjacent. So the hypotenuse is x and the adjacent is 3. What we're going to do, if we call this box, we know that box squared plus 3 squared is x squared, the Pythagorean identity. So box squared is x squared minus 9. And sure enough, the missing side there becomes the square root of x squared minus 9. And this is very good for us because it should match something you have in the problem. If you don't see the same result somewhere in there, variation, then you know you did something incorrectly. So this side of the triangle becomes square root of x squared minus 9. Once we have secant theta is x over 3, now we're ready to get the x and dx. So multiplying by 3, we get that x is 3 secant theta, and then from there we're going to get that dx is 3 secant theta tangent theta d theta. And we're going to use those in our substitution. We're now ready to do a substitution. Writing this out again, I have the integral of square root x squared minus 9 over x cubed dx. Substituting, we had that x squared minus 9 was 9 tangent squared. So we get to write this as square root of 9 tangent squared theta. We then need our dx, and we know that is 3 secant theta tangent theta d theta. And now for our substitution, x is 3 secant theta, and we are cubing that. Once we've done that, we're now going to have a trig integral that we're going to try and finish. Working this through, we get the integral of square root of 9 tangent squared is a 3 tangent. Then we've got a 3 secant theta tan theta d theta. And then on the bottom, 3 cubed is 27 secant cubed theta. And of course, we're going to simplify. We've got 3 times 3, 9 over 27 is 1/3. We've got a secant theta and a tangent squared theta all over a secant cubed theta d theta. I'm going to simplify. This secant cancels, and I have secant theta squared. One easy way of doing this is, we know this is 1/3 tangent squared theta over secant squared theta d theta. So I'm going to change this to sines and cosines. We'll go to the next page. And this is 1/3 tangent squared is sine squared theta over cosine squared theta. And 1 over secant squared is cosine squared. These will cancel, and we're left with 1/3 the integral of sine squared theta d theta. And this is a special approach to doing this trig integral. This will be the half angle formula, so this gets replaced with 1 minus cosine of the double angle over 2, and 1/3 and 1/2. We can move that in front. We've got 1/6, 1 minus cosine of the double angle. This is going to be 1/6 theta minus 1/2 sine 2 theta plus a constant. Now we're not finished because we have to get our answer in terms of x. So we now have to replace all the thetas and the trig thetas with expressions with x. To do that, we're going to go back here, and I'm going to put the key that I had, especially this part with the triangle. This second step right here, this is the part we use to get our answer. So we're going to put x over 3 is secant theta. Moving down here, we're going to put the key and see if we can get that answer. So we have that x over 3 is secant theta. Related to that, we had the right triangle, where we had theta right here, and we had that it was hypotenuse over adjacent, and this was square root of x squared minus 9. But notice our angle is 2 theta, but we only have the triangle with theta. Sine of the double angle is 2 sine theta cosine theta. Because our original key only has the angle theta, we have to change everything to that. So working the 1/6 through, I have 1/6 theta minus a 6 times the 1, so minus a 6 sine theta cosine theta. I'm now ready to use the triangle in this first sentence to get the missing theta and trig values. For this one, to get theta, I need inverse secant of both sides, because that will undo that. So right here I have 1/6 inverse secant x over 3 minus 1/6, and now I'm going to put the sine and I'm going to put the cosine. Now we look to the triangle and we see sine of theta, which will be opposite over adjacent, so it's square root of x squared minus 9. I'm sorry, opposite over hypotenuse, not adjacent. And cosine, which is adjacent over hypotenuse, which is x, adjacent, sorry guys, 3 over x. And now we're going to write the answer, distributing everything through and simplifying. Our answer becomes 1/6 the inverse secant of x over 3, and then we have this 3, of course, with the 6, and this becomes minus radical x squared minus 9 over 2x squared plus a constant.